This video, we're going to look at our last AP practice problem, which was AP practice problem J. I mentioned in my directions on this that due to how they've changed the content this year, there's certain things that they've omitted. C is not asked, so I'm going to skip going over C. C has to do with average value, which is a formula that requires an integral, and we didn't go over it, and they're not expecting you to know it. All right, so we'll look at A, B, and D. A, B, and D make up 6 total points. So the part C would have been the other 3 points. So basically, I'm going to go over 6 of the 9 points that you could have gotten. All right. So this is yet another one of these. They give you a graphical representation of a function. And we should note that this is f itself. So this is the function f. It's made up of a coarse circle and some line segments. Now, the weird thing is, they don't give us the right end interval. They just tell us it's positive. So we know all these spots hit somewhere. And then there's this last line segment connecting to some varying spot. It could be way out here. It could be in here. In fact, one of the problems, they actually limit where it could be. They say it has to be 3 or greater. But for now, it's wherever we can put it so long as it's greater than 0. So they tell us that in this first line. And then they tell us, I also mentioned of what it was made of. And yep, that's it. All right. So part A is another one of those gimme questions, average rate of change, which is a fancy way of asking for the slope, something that an algebra student could do. So in order to find average rate of change, we're going to look at this interval from -5 to 0, and basically this is the x interval. We just need the y values on the end and do the slope of them. So it's just show the computations lead to my answer. Average rate of change is essentially slope. I need it on this interval, so I'm going to do y2 minus y1, or basically the f of 0 gives me the y value. So I'm going to do y2 minus y1 over x2 minus x1. Well, here's your y2, your y1, your x2, your x1. Down here, 0 minus -5 comes out as 5. You need these function values, but you can get them right off the picture. 0 has a height of 2, and -5 has a height of 0. So that's how I got those two. And it calculates down to 2/5. There are no units associated with this, so they don't actually ask us, what are the units. There's really no context to it, so we just get that value. Getting that value is 1 point, so just be careful when you calculate, because if you make a mistake, you lose the point. So 2/5 answers A. B is a bit interesting. Now, I answered it slightly differently than they did in their key if somebody were to look at the AP solution to this, but I kind of like my way better because it connects to the second derivative. They basically go to the first derivative and talk about change of the first derivative. So I'm just going to go directly to the second derivative because that's what talks about concavity. So they tell us for that interval on which it's defined, g is now an integral function. So g is equal to the integral from -1 to x of f of t dt. Remember, the t is just a dummy variable. It's just basically talking areas of this function. So realize the g comes out, what's the value of this function? It's the area between -1 and wherever you end up on that picture. So with this, it wants me to find the coordinates of the points of inflection of g. So g I don't have a picture of, but I can work with this to figure it out. So where are the inflection points for g? Let's talk about them. So the way I decided to do it was inflection points are where concavity changes. The tool for concavity is the second derivative of the function that you're talking about. So since we're talking about function g, I need to think about g's second derivative. Concavity is where inflection changes, where inflection point is where concavity changes. So I basically want to look at where concavity changes is basically where the second derivative changes sign. If the second derivative goes from positive to negative, or negative to positive, it's basically changing from concave up to concave down, or vice versa, and that's by definition an inflection point where concavity changes. So my first goal is to be able to get something about the second derivative of g. The second derivative of g is going to be important for being able to know about what's happening with the concavity. So you can see here, how did I get them? Well, I need to talk about what's the derivative of g, and then what's the second derivative. Well, the derivative of g is the important part, because what's g prime? It's the derivative of this. How do I take a derivative of an integral? Well, when I take a derivative of the integral, they cancel, and it just throws that x in. So g prime is the derivative of this, and the derivative of the integral is just the function itself, f of x. So now that I know g prime of x is f of x, I can find g double prime. Basically, if I take the derivative of this, it throws another prime on it, and take the derivative of this, it throws a single prime on it. So what is the second derivative of g? It's actually the first derivative of f. Now, how am I going to get information about the first derivative of f? Well, the derivative of f, I don't have a picture of per se. I don't have a graph of f prime of x, but f prime of x is the slopes of f. So I really do have information. If I come up here, I can see what the slopes are somewhat. Like these are negative slopes, these are positive slopes, these are negative slopes. So basically, whatever these slopes are the values of f prime. So how am I going to talk about concavity about g? Well, I need to know where g double prime changes sign. That's telling me where does f prime change sign. And f prime changes sign, since f prime is the slopes, it's basically this changes sign when we go from positive to negative slope. So in the picture, where does that happen? Well, if I now know that I'm looking for changes in slope from positive to negative on f, well, they happen in two spots. It's negative here. It actually goes to 0 right at the spot. But basically, they're negative slopes, and then they change to positive slopes. That occurs at -3. It also changes one more time. It changes from positive slopes to negative slopes at x equals 0. All right, so -3 and 0, if we work backwards, -3 and 0 are where f prime changes sign. That means they're where g double prime changes sign. If g double prime is changing sign, that's indicative of an inflection point. So I basically explained what I wrote, but hopefully now you can see how I formulated on the paper. I said inflection points occur where the second derivative changes sign, which is where f prime of x changes sign. Where does that happen? Well, f prime of x changes sign. This occurs where the slopes of f go from positive to negative, or negative to positive, which happens at those two spots that I came up with. So basically for this problem, we had the 1 point up here. This one has 3 points associated with it. So 1 point for just getting that derivative, if you can just do this on both sides, which if you know the fundamental theorem of calculus well and you've done these AP problems, they ask this over and over again, there's a point. There's another point for identifying these, and the other point for basically justifying everything, connecting that these things, basically the concavity of one is the slopes of the other, and we can look for the change in those slopes and find our change in concavity spots. All right, 3 points there. I said we were going to skip C, so I'll make this video a little shorter. Then the last one is just doing a derivative, but it's a little funky. We'll come back and look at this first part. They tell us to assume C is greater than 3. There's a reason for this, because basically you can't answer the question. If they didn't put this here, you could turn around and go, oh, well, it's possible it doesn't have an answer. So this is just here to kind of cover their rear ends and make sure that nobody critiques their problem. So in the end, we'll look at why they said this. The major part of the question is they give us h prime of x. They define yet another function, not h prime, h of x. They give us h of x, and they tell us it's equal to f of x over 2. So really the only difference in these functions is this inner part of f. They want us to then find h prime of 6 in terms of c. So the weird thing is this in terms of c part. We'll come back to it. The very first part that should be that should ring a bell is, well, I need h prime of 6. So if I want h prime of 6, I need h prime of x. What's the derivative of this? It's going to be based on the derivative of this. And since they gave us the f function, we're going to use this to talk about values of h of x. So h of x is f of x over 2. How do I do the derivative? Well, the derivative of this side is just going to be a symbol, h prime of x. How do I do the derivative of this? Well, this is a chain rule. It's a function of a function. There's an outer function, which is just called f. There's an inner function, which is the function x over 2. Or I'm going to think of it as 1/2 x, because 1/2 x is easy to work with as far as a derivative. So when I take the derivative of this, I'm going to use the chain rule. I'm going to take the derivative of the outer function and leave the inner alone. So derivative of the outer function, what's f's derivative, is literally f prime. Leave the inside alone. And then the chain rule says, well, if this is a function itself, it's a kind of complicated thing, I need to multiply by the derivative of that inside function. So I just showed that as a symbol. I go, well, here's the inner function. I put the tick mark because I'm going to take its derivative. You could use a quotient rule on this, but you don't have to because it's 1/2. Basically, this is 1/2 x. Derivative of 1/2 x is just 1/2. So that kicks the 1/2 out here, f prime of x over 2. So what's h prime of x? It's f prime of x over 2 times 1/2. That gets you a point for calculating that derivative correctly and knowing how basically to read this notation and do the chain rule. So coming up next then is, well, if I know h prime of x, let me find h prime of 6. Well, h prime of 6 is literally just plugging 6 into this thing. If you put the 6 here, it tells you it's 1/2 f prime of 3. All right, so what then do I do with this? Because they want it in terms of c. So I have h prime of 6, but there's no c in it. So I have to think of how am I going to get c incorporated? Well, f prime of 3, what should that be? This is where the c has to be greater than 3 comes in, because what does f prime of 3 mean? It means the slope at 3. If we come up to this picture, let's assume 3 is right around where the pen is. If 3 is here, well, what's its derivative? It's the slope at 3. The good news is the slope at 3 is the same as the slope all along this line segment. So if I know the slope of this line segment, I know the slope at 3. And this is why they said c has to be bigger than 3, because if they didn't make c bigger than 3, say c was over here, and 3 was here, well, then there would be no derivative at 3 because the line segment wouldn't make it that far. By forcing c to the right of 3, it allows this line segment to be formed past 3, and then 3 will have a derivative that's the same as this line segment. So it explains why they gave that little proviso, because they wanted to make sure somebody didn't come back and go, well, what if c's over here and I can't get it? So they guaranteed that it will exist. So then the way I'm going to replace this f prime of 3 is I'm going to look at, well, what's the slope what's the slope at 3 of this graph? Well, it's the slope of this segment. What's the slope of this segment? Well, use y2 minus y1 over x2 minus x1. This is the second point. Its coordinates are c comma 0, and this is your first point. Its coordinates are 0 comma 2. So what I did was I noted this in case someone was wondering about my work. I said the derivative of x equals 3 will be the slope of the line segment connecting those two spots, the 0, 2, and the c0. What's the slope between them? Well, just calculate that slope. y2 minus y1 over x2 minus x1. Basically, now you know what they mean by in terms of c. This does not come out as a number because I don't know what c is. I do know f of c, the y value associated with c is, because c is a root, is 0. F of 0, I know from the picture, is 2. C, I don't know. All I know is it's bigger than 3, but I don't know what number bigger than 3 is. I'm just going to leave it as c, and then the other part's 0. So now this would actually be an answer. Here's the h prime of 6 in terms of c. But if you want to knock it down to get their nice answer, 0 minus 2 is negative 2, c minus 0 is c. So you're doing half, and you have negative 2 over c. The 2's cancel, and it leaves you with negative 1 over c. So the value of h prime of 6 is actually, according to this function, it's whatever 1 over c is. So if you knew what c was, if c was like 7, well, this would come out as negative 1/7. In fact, we don't even know what c is. So long as c is greater than 3, whatever number you made it, there would be your derivative. All right, so I think I talked about the point values here. I said the point value for the derivative and then point value for the end answer, which I think is not many points for a problem that has a decent amount of work in it, because there's definitely spots you can make mistakes, or obviously the concepts might be difficult. All right, so those are how you get the 6 points. Once again, C was skipped, and hopefully you're getting the idea. They sure do ask this a lot. Another problem where they have you relate, a derivative to a, second derivative to a derivative of another function and all that junk, and chain rules back in this one. And some hard concept here, but at the very least, getting 1 point out of this, if you couldn't really finish it off conceptually, at least getting the derivative would be something you'd want to be able to do. All right. Well, we're out of time. This is the final AP practice problem. So this ends this series of them. Hopefully, if you've gone through all of the problems and gone through all of the keys and gone through all these video solutions, I would hope that you're prepared for most of, or if not all of, what they'll ask you. All right. Well, that ends this. Good luck, and that's it. Bye.